Subshells orbitals. Shells subdivided into subshells S, P, D, F. Number of subshells equals value of n for that shell when n equals 1 means 1 subshell S. When n equals 2 means 2 subshells S, P. When n equals 3 means 3 subshells S, P, D. When n equals 4 means 4 subshells S, P, D, F. Diagram showing shells and subshells for n equals 1 to n equals 4. Size and visualization. Atoms are extremely small, not visible to naked eye. Seen with transmission electron microscope, electrons are clouds with probabilistic location around nucleus. Probabilistic location means the exact position of an electron cannot be known, only the likelihood of finding it in a certain region around the nucleus. Electron capacity of shells. Maximum electrons in shell equals 2n squared. N means shell number. For K shell, n equals 1, contains maximum 2 electrons. For L shell, n equals 2, contains maximum 8 electrons. For M shell, n equals 3, contains maximum 18 electrons. Electron filling continues till all electrons in atom are placed. Electron capacity of subshells. S subshell contains 2 electrons. P subshell contains 6 electrons. D subshell contains 10 electrons. F subshell contains 14 electrons. Example: first shell. K has only S subshell with 2 electrons. Atomic number and mass number matter is made of atoms. Atoms are made of 3 fundamental particles: electrons, protons, neutrons. All elements have these same particles. Atoms of different elements differ in the number of fundamental particles, especially the number of protons. Atomic number definition: number of protons in an atom, fixed for every element. Symbol Z, since atoms are neutral. And now number of electrons, number of protons. Example: oxygen has 8 protons. Its atomic number is 8. Atomic number definition: number of protons in an atom, fixed for every element, symbol Z, since atoms are neutral. And now number of electrons, number of protons. Example, oxygen has 8 protons. Its atomic number is 8. Importance of atomic number unique for every element helps identify the element. Periodic table is arranged by increasing atomic numbers. Mass number A. Definition: total number of protons plus neutrons. Symbol A. Electron mass is very small and ignored. Also called the nuclear number. Example, oxygen atom has 8 protons and 8 neutrons. Mass number A equals 8 plus 8 equals 16, symbolized as 1680. For neutron number calculation, formula used is N equals A minus Z. Example, sulfur has mass number 32, atomic number 16 by using formula. Its neutron number is calculated ions vs isotopes. Ions forms as a result of change in number of electrons. Isotopes form as a result of change in number of neutrons. Example, barium, given 137,556. Ba. Barium has 56 protons and 56 electrons. So neutrons is calculated by using formulas. Practice question. Calculate number of protons, electrons, and neutrons in following elements. Isotopes and their masses. All the atoms of an element must necessarily have the same atomic number, but their mass number may vary depending upon the number of neutrons present in the nucleus. Atoms of the same element having different number of neutrons in their nuclei are called isotopes. There are 2 isotopes of chlorine, chlorine 35 and chlorine 37. Chlorine 35 has 17 proton and 18 neutron, and chlorine 37 has 17 proton and 20 neutron, P-17 and -20. Examples of isotopes: carbon isotopes. These isotopes have 6, 7, and 8 neutrons respectively. Hydrogen isotopes. These are called hydrogen, protium, deuterium, and tritium. They has no neutron. Chemical and physical properties of isotopes. Chemical properties are similar for isotopes because they depend on the number of electrons. Physical properties are different due to difference in mass. Relative mass of hydrogen isotopes has thrice the mass of What are radioactive isotopes? Some isotopes have unstable nuclei. These isotopes emit energy in the form of radiation. The process is called radioactivity. Such isotopes are called radioactive isotopes. Radioactive decay. A radioactive isotope transforms into another element by emitting radiation. This process is called radioactive decay. The new element may be stable or radioactive. Examples of radioactive decay are conversion of uranium to thorium, thorium to protactinium, and bismuth to thallium. Why do isotopes emit radiation? To become more stable, isotopes release extra energy. The emitted radiation helps the nucleus to stabilize.